representing AIRBORN as a business development manager for Europe. With this presentation today, I would like to share with you the work that we've done in the past few years with regards to fiber technology. AIRBORN has invested a considerable amount of engineering resources, time, money, to really bring innovation to this growing market, which is space. I'm going to share with you the starting point was the challenges. We wanted to look at the challenges that are most commonly seen in this market. So there is a common denominator there. We see an increased demand for high bandwidth, connecting system and subsystems. They need to be reliable. So system integrity is very important throughout the mission, throughout the time of the whole mission, especially under hostile circumstances, like could be, what you found out in space or during a launch phase. Then we see an increase of modularity approach. Let's say satellite builders are building individual modules that are already pre-built and put on the shelves. So with this modularity approach, what happens is each individual product can be built to specification when that order comes through. So with that modularity, you also need the possibility to make connection very easily and very quickly. So for many companies out there who are already using this approach, the goal is to, from the time of the order, through the manufacturing process or the assembly process, out of the door within 2 hours. So in order to do that, obviously you'll be facing considerable amount of challenges. Also, we see a recurring denominator, which is cost, reducing weight, improving the reliability. Okay. And also, we see a fresh blood coming into this market. The new designing engineers are really willing to challenge the status quo, wanting to look at new technologies, taking away what's been done so far and looking out for what's out there. How can we simplify what we do today in a seamless way? So obviously all this comes at a cost, so there are challenges, but we don't grow because things are easy. We grow because we face challenges. We every day get out of bed and try to change the way things are done to make them better. Okay, so what perhaps is most important here is how can we overcome all those challenges that we are facing? Being seamless. Give me a solution that is really reliable, that can provide a migration path for future technologies. So I can deploy today, but I can also move on with technology as soon as they come along and they become available. I'm able to integrate all these technologies. So I got a migration path. I don't have to rip and replace. I don't have to waste all the money and the investment I've done so far. So at AIRBORN, what we thought was, how can we put the best of two worlds together? So with everything we said so far, how can we bring innovation to the highest point? So what we've done is to, again, put together the best of two worlds. So it's a solution that allows you to have a copper interface, which is a traditional connector, without having to change anything in the design, in the PC board design, in the equipment design that you currently have. But then also have the advantages of fiber, therefore high bandwidth, reliability in terms of immunity from radio frequency interference, electromagnetic interference, having different channels for different systems to communicate, and obviously also very light in weight. So how can I have an interface that is robust? And this is what I normally know as an interface. Can be a traditional connector, but at the same time mix that with a technology like fiber optic technology. So this active optical cable that we are presenting here today gives you exactly that. So what we have, instead of having to build fiber optic components on the chipset systems, on the board, or having transceivers, we're taking that out from the board and we place it into the back of the connector. So the technology itself is within the connector. So what we have is an optical engine built at the back, in the back shell of the connector. So a conversion from an electrical input coming from your system, from your subsystem, and interfacing with a standard connector is converted into an optical signal using a VCSEL laser, and then shoot down to the fiber cable. And by saying that is we can now reach long distances in space up to 30 meters, outer space 100 meters, with an aggregated bandwidth of 50 gig. So it's 12.5 gig per channel, up to 4 channels for now. Now at the other end, we have an identical interface reconverting the optical signal into an electrical signal, and it's done. It's very simple. We've used an existing technology. This technology has been used in data centers. Service providers have been using it in order to upgrade their point of presence, in order to upgrade services that they provide to users like you and I into their homes. So we've taken that technology and moved it into a space environment. So obviously there's loads of tests have to be done in order to qualify this technology to be able to be deployed out in space. So again, what we have here when we look at all the benefits that fiber can give you, so low maintenance, for instance. Fiber is notoriously famous for being hard to work with, hard to install, hard to maintain because it gets very dirty. So now we take that away because we have a copper interface with the benefit of the copper. So low maintenance. Once that connector is in place and is being mounted onto the board, it's in place. It's not going to go anywhere. It's not going to get dirty. The fiber cable and the optical engine within the chip set of the connector will do all the rest. So now we can reach high bandwidth at high speed for longer distances within a given system. But the advantages are you don't have to change anything in your design as long as you provide enough power on a pin to feed into our interface. That is done. That's all we need. Okay, it's half a watt of power at 3.5 volts. So that's all is needed. So you can easily drop this new system into your existing system. Now, and when it comes to interfaces, we often face the challenge or the question, well, can I use my connectors? I don't want to change my specification. I want to carry on, but I want to introduce this new migration path. I want to be able to now consolidate multiple systems down onto a single fiber strand, because this is what you can do. We can apply any different interface to that technology. So it can be a 3A999, a nano connector, a micro connector, even a custom connector. It doesn't really matter. We can mount on that interface anything we like, and then it plugs into a given system. And we're doing this today. So this is not something in the future. This is something that we have ready available. And lots of tests have been done. Often the question is, have you tested it? Is out there? Yes, this technology is already in space. We've done specification testing according to specific customer requirements. So we can look at specific requirements and build the technology around it. So this is really what AIRBORN does on a regular basis. Now, when we talk to future-proof and also the investment, well, it's not a disruptive technology. Disruptive technologies are good, but can be very dangerous because you don't really know what you're stepping into. Now, here we have the possibility of using a proven technology. It's been used in data centers for at least 10 years. Currently used in service provider space. So that conversion from optical to electrical and vice versa, electrical to optical, is done. We just integrated it into the connectors. We've tested it, we qualified it, and we put it into space already. So your risks are very minimum. Our customers can actually rely on this technology today because it's already out there. So there is minimum amount of risk associated with this new technology, and that's a great advantage. It's probably what the fear factor normally is, do I really want to start with a new technology now that I know this is working? Well, yes, it's worth it because it's proven, and it's proven today. So there are different type of configuration. There is no limit to what we can do in terms of assembly. We can do an AOC, so active optical cable to active optical cable, or a passive connector, can be an SC, an LC, an ST, depending on which system, optical systems you've got. It can be a passive connector to an active AOC. So let's say that could be an interface, can be a consolidation point, or can be just attaching to a fiber system for communications, for imaging. So it's not limited to any applications. And also we're looking at introducing power along the fiber strand. So now you have also the possibility to drive power to activate some other systems along the way. So questions are, when does it make sense? Should I use the traditional harness cable, or should I start considering this technology? Well, if distances are greater than 3 meters, if you got demand for high bandwidth, reliability, signal integrity is a must because of mission critical applications that you are supporting out in space. You need long distances, perhaps 20 meters, 10 meters, then it makes sense. It makes total sense to start considering this technology. So it's not always the case, but we see more and more applications out there that will benefit from this new technology. And just to conclude, AIRBORN is based in the United States with locations, manufacturing locations into Europe, sales offices across the world. So we've been in the space business for over 60 years, so it's a company that can be trusted. We will continue to develop new technology as we did with this active optical cable. And there is a legacy there to prove all the work that we've done throughout the past 60 years. So this is not the first time that we deploy technology into space. We do it every day, day in, day out, and it's out there. So if you want to see more about this technology, and we want to talk more about how it can be used, we got a booth over there, A18. Come and visit us, and we can also show you some samples. We got some real samples of the products ready to go today. Thank you. Any questions? But if you think of any questions, again, we are on. Please. You have a mic?
Hi, thank you for your presentation.
Thank you.
In space and in assembly areas where space equipment is put together on the ground. It's usually a clean room type of situations. Where does the benefit of contamination or non-contamination come from in employing electrical pins instead of fiber optic termini?
Well, because the actual fiber optic components are not on the actual board. So we've taken that away from the board. So the actual design of the board or the technology or the system or subsystem used remain the same. So now we just bring everything into the connector. So there is no interference. Even when it comes to security, for instance, this is a major point we all often face is, well, we deal with very sensitive information here. And we don't look at packages. We just take whatever signal comes, whatever protocol. This is a protocol agnostic technology. So we take that protocol, we convert it, and we send it down to the fiber. So in terms of interference or introducing an alien technology or an alien element, that is literally inexistent.
Okay, thank you.
Thank you.